This is Bruce Whitfield. This is ECN 423 Section 1 Homework 10, and this is the VHDL for my item purchased counter. I have the entity set up with clock and item purchase reset in standard logic, and then I have a purchased item in standard logic, 3-bit. And this is going to be the item that is purchased, which is 1 hot, so it would be gum, chips, or soda. That is the output from the finite state machine. That will be the input into the IP counter, and it will use that. So if it's anything but 0, it's going to increment the counter. And then the output, which is 3-bit, is the number of purchased items. And then here's the architecture. I have a temp signal. And the process with clock and the IP reset. If IP reset is 1, then temp is 000, and then if clock event happens, if no items purchased, then temp is just equal to temp, else increment temp by 1. I end that process and set number of purchased items to temp, and that is it for the VHDL for the item purchased counter. I'm going to show a simulation of the counter, and so you got your signals: clock, IP reset, number of purchased items, and the temporary signal. You see right here at the first rising edge, reset is enabled, and it will set the number of purchased items to 0, and it will, and then at the next rising edge, it will set purchased item to 0. And so when the purchased item is set to 0, the number of PI is still 0 purchased items, and then at the next rising edge, when the purchased item input is set to 1, then the number of purchased items is set to 1. And basically, through the simulation, I just keep the purchased item that is selected, that is input into the counter. I just leave it at 1. And so this will just show the number of purchased items as it goes to the next rising edge. It just increases. So it goes from 1 to 2 to 3 to 4 to 5 to 6 to 7. And since I only have 3 items, and I have 7 of those items in the vending machine, this counter can only go up to 7. So then that's why it restarts at 0. And that concludes the IP counter.